Well, welcome back to lesson 6.4, where we will be talking about three different special kinds of parallelograms. We will talk about rhombuses, rectangles, and squares in this lesson. And we are going to talk about special properties of each of these three types of parallelograms, and as well as talking about what properties we have when their diagonals intersect each other. So let's go ahead and get started. And our focus question is, how are rhombuses, rectangles, and squares related? That's what we will be looking at. So first of all, let's take a look at our special parallelograms. And the first one you can probably figure out by looking at the picture that this is a rhombus. And a rhombus is just a parallelogram where all four of its sides are equal in length. The second one you could probably also figure out, that one is a rectangle. When you have four right angles, it's a rectangle. And then when you combine these two together where you have four right angles and all four sides are congruent, we call that a square. So here is a picture called a Venn diagram that defines each of the different types of parallelograms, and you can see that a square is both a rhombus and a rectangle, and so every square is a rhombus, but not every rhombus is a square, and every square is a rectangle, but not every rectangle is a square. So a couple of key things to remember: a rhombus is a rectangle only if it's a square. And a rectangle is only a rhombus if it's a square. So a square is a special type of both a rhombus and a rectangle. That could be a little bit confusing, so I thought I would clarify that. So here's a problem, and it says, assume that we have a parallelogram. Remember, this little rectangle symbol here means parallelogram. ABCD is a rhombus. Is it a rhombus, a rectangle, or a square, and how do you know? Well, if we look at the picture ABCD, we are given that angle B is a right angle, so we know it's a rectangle. Opposite angles of parallelograms are congruent, so that gives us angle B and angle D being equal to 90 degrees. But then we also know in parallelograms that the consecutive angles are supplementary, so that means angle A and angle C are also 90. So since we have four right angles, ABCD is a rectangle. We cannot say that it's a square because we don't know anything about the side lengths. So what about, in your got it section here, what about parallelogram EFGH? What do you think that one is? Is that one a rhombus, a rectangle, or a square? And how do you know? Well, this one, they don't give us any information about the angles, and they only tell us that two of the sides are congruent. And since we know it's already a parallelogram, we know the opposite sides are congruent to each other, so we do know that all four sides are congruent. So therefore, in this one, we would say that this one definitely is a rhombus. Here are a couple of theorems that we will be using. If we have a parallelogram and we know that the four sides are congruent, if it's a rhombus, then we know that the diagonals are perpendicular to each other. We know that diagonal AC and BD are perpendicular, which means all of these would be right angles. Our second theorem, 6.14, says if we have a rhombus, then each diagonal bisects a pair of opposite angles. So be careful on this one. What this one says is that diagonal BD bisects angle D into two congruent angles, okay? And it bisects angle B into two congruent angles. We know that these two angles are congruent, so we know that 3 is congruent to 4 and 7 is congruent to 8. But we also know 7 and 3 are congruent and 8 and 4 are congruent. So all four of those will be congruent to each other. And likewise with angle A and angle C. So here's a problem where we're going to find some of those angle measures. It says, what are the measures of the numbered angles in a rhombus ABCD? So we know this is a rhombus, so we know that all four sides are congruent. And they give us this part of angle B up here. So what can we figure out from that? What do we know just from that information? And first off, we know that the diagonals of a rhombus are perpendicular. So we know that angle 1 right away has to be 90 degrees. Okay. So what about angle 2? What do we know about angle 2? Well, we know it's a parallelogram, and it's a special kind of parallelogram. It's a rhombus. Angle 2, if we have side AB and CD being parallel, then you can see this sideways Z. Angle 2 is actually an alternate interior angle. right here, and it's congruent to the angle B that they give us. So that one's actually equal to 58 degrees by the alternate interior angle theorem. And then angle 3, similarly, we can figure out angle 3 is also equal to 58 degrees because the diagonals bisect each other. Okay, so because we knew angle 2 was 58, angle 3 has to be 58 because BD is a diagonal and it bisects angle D. So now we've got angles 1, 2, and 3. How do we get angle 4? Well, angle 4 we could figure out using just this small triangle on the bottom. We already know 1 and 3. So if we add those two together, we can use the triangle sum theorem, and they add to 180. So we can just plug those in that we know and solve for angle 4, and we get 32 degrees. Here's one for you to try. Go ahead and pause the video. See if you can come up with angles 1 through 4. All right, hope you gave that a try. Here are your solutions. Since we know that QR, side QR, and side QP are congruent because this is a rhombus, we know all the sides are equal in length, that tells us that angle 1 and angle 3 are congruent by the isosceles triangle theorem. And if these two angles are congruent, then we can just subtract the 104 from 180, which leaves us 76 degrees. And if we split that in half, these two have to be equal, so that gives us 38 degrees for angles 1 and 3. Well, we also know angle Q and S are congruent. They're opposite angles in a parallelogram. So similarly, since angle S is 104, we could find 2 and 4. We know PS and RS are congruent. By the same theorem, the isosceles triangle theorem, we know 2 and 4 are congruent. And we have 76 degrees left over from the 104. And if we divide that in half, we get 38 degrees for each of those. So our third theorem, it says, if we have a parallelogram that's a rectangle, then we know that these two rectangles' diagonals are congruent in length. They're equal in length. AC is congruent to BD. So what if they give us the length of the diagonal as an algebraic expression? Can we find the length of that diagonal? Well, what we would do in this case is we would set each of those equal. SF is congruent to BR, and then just simply solve for x. We get x equal to 9. Okay, so what we would have to do at that point is substitute in 9 for each of these variables, or one of the variables. They're going to be congruent, so it doesn't matter which one you substitute into. They substituted into RB, so they put 9 in for x. So you got 9 times 5 is 45 minus 12 gives you 33. SF similarly should be equal to 33 if you substitute in 9 for x up here. So down at the bottom is another opportunity for you to try one on your own. It says if figure LMNO is a rectangle, then they give you the length of LN is an algebraic expression, that's one diagonal. The other diagonal is 2x plus 13. What are the lengths of the diagonals? Well, the diagonals, if we go ahead and set those two equal, we get x equal to 15. So to find the length of the diagonal, you would just substitute in 15 to either one of those expressions. And 4 times 15, I'll just substitute into ln. 4 times 15 would be 60 minus 17, which would be 43. So each of those diagonals would be 43 units. And I should write that in here, 43. And that's equal to MO, which is equal to ln. All right, so what about the part B? It says, what type of triangle is PMN? Triangle PMN up here, this little triangle on the top. And it turns out that that is an isosceles triangle because these diagonals in every rectangle bisect each other. So we know that MP and PN would be congruent, and that would give us an isosceles triangle. Here is your lesson check. Please have this finished for tomorrow when you come to class, and I'll see you then.